Okay, everybody. So, chapter 5, fourth edition, lecture, 30 slides, how to test and debug, which I know uh, a lot of the troubles that we've been having would have been beneficial to cover this information sooner. But it's kind of a chicken and egg thing. Do you learn to code and then learn to troubleshoot it, or do you learn to troubleshoot it and then you learn to code? Right? So it's kind of a chicken and egg thing as I see it. Is you got to get so far into learning the fundamentals before you learn to troubleshoot. Otherwise, if you're learning to troubleshoot before you learn to code, anyways, that's kind of how I see it. So we got our objectives as we always do. You know, the applied is kind of like your hands-on, what we'll do in lab. The knowledge, go through these knowledge objectives. Distinguish between testing and debugging. So there's a difference in the language and what they mean. What is the difference between testing and debugging? Then we'll talk about some different kinds of errors. This is in any programming class. We'll talk about kinds of errors. Then we'll get into some more specific problems, like floating point number problems, and how to fix that. Some types of problems that can arise if you don't use strict. And so you've seen this use strict in this book and in these labs. Really, what is that use strict? Maybe we need to dive a little deeper into use strict. And then if you don't use it, you know, some problems that can come up. And so as a rule of thumb, you do just want to put that little line up at the top of your script. Use strict, and then that will help you avoid problems. That's like the short version of this. Put that at the top. That's a good practice. And then how to create a testing plan. So when you're testing software, you're looking for problems. And there are full-time jobs called testers. And these are people that are just hired to break your software. And so there's, again, full-time jobs of people, and they might know how to write code, they might not know how to write code, but they're just there to break your software. And if you work for a large corporation with the, if you work for Facebook, certainly there's people at Facebook that go onto the website and they just try and break it, try and find holes. And so they have plans on how to test the software. And then we'll talk about what is this tracing, what does that mean with console.logs. We've been using console logs a little bit, and you could use them for this thing called tracing that'll help you debug some problems. So what is the difference between testing and debugging? Testing, when I think of testing, again, I think of people trying to break your software. So they're trying to find the errors before it goes into production. You might hear of the job called quality assurance, QA. They're often called QA testers. And again, sometimes these QA testers, full-time job, sometimes these QA testers have a software development background. Sometimes they're just people off of the street that they're taught how to try and break software. So typically, again, quality assurance, QA, quality assurance, testing. And I think of QA jobs as a stepping stone in the software development industry. So, like if you're going to be a technician, like a help desk person, you typically go help desk jobs, and then you go administrator jobs. So help desk is your entry level, and then administrator is kind of like a rung up in the corporate ladder. And so I think of QA jobs sometimes as a stepping stone, like you're getting into the software development world, even though you might not be writing code every day. And so I think of that as a stepping stone, kind of like the help desk is to an administrator. QA is kind of like your entry level into this industry. And you don't even have to know how to write code to test applications. A lot of times when you guys are testing your own applications, right? So you write program, and this is calc miles per gallon. So miles per gallon HTML. And you just, you throw some numbers in and you see if it gets the right results, right? So if you think about the things that you've done in JavaScript, you probably test it with like 2 or 3 inputs and you call it good, right? But really, if you're trying to break this, you're going to be throwing in all sorts of, you're trying to throw in letters, trying to throw in negative values, trying to just be as, you're trying to think of all the inputs that an end user could potentially give you, right? Even on accident, what if the user, did this kind of stuff on accident or, typed in whatever. So, there are testing languages. By languages, you can write software, you can build software to test your software. And so you think about this, what if you want to try, here's my inputs, what's my expected output? So you can write software to supply 1 million expected inputs with 1 million expected outputs and make sure that all 1 million cases give you the expected output. So there's, again, these full-time testers, that might be what they do. They might write software. Again, they might know software development, they might not. Oftentimes, this is called unit testing. Unit testing is this idea of writing software to test software. See, we're really inefficient at testing our software. We're just going to test a couple values. We're going to try 2 or 3 inputs, make sure we got 2 or 3 outputs, and expect every other billion cases that are out there are going to work. So unit testing is kind of this idea of writing software to test your software, right? So that you can give, using a loop, right? You can loop through 1 million inputs and tell that software what the expected output is, again, just to make sure that it comes out the way you expect it to. So that's what testing is. We're not necessarily in this class gonna use unit testing, but just knowing that it exists, right? It is out there. That's how our software should be verified that it works, right? It should go through some sort of unit testing, software testing and trying to break your code. Debugging then is the process of, okay, once you find a problem, fixing it, right? Testing is finding the problem, debugging is fixing the problem. maybe you've heard of where the term where debugging comes into process. You know, in the old days of computers, computers were literally the size of a room. So you could think of like the most basic computer that can add 2 plus 2. In the early days, to add 2 plus 2 on a computer, you had a physical machine that was the size of this room. And it had really big mechanical parts and these big wires that would run all across the room, right? And these, you know, hard drives that were the size of a monitor, you know, or bigger, like these huge hard drives, and these big mechanical read-write heads that would go onto these hard drives. So the story is that a moth, you know, some sort of, I don't know how big the moth was, got stuck in between a read and write head, between the disk and between the mechanical arm, right, that would write on the disk, right? So there was a physical bug in this giant room that got stuck, which was causing the program not to work. And so by going into the room, removing the bug, literally the moth, removing it from the read and write head, fixed the problem. So that's where the term debugging supposedly came from, right? Literally removing a physical bug out of the machine. But that's fixing a problem. 3 types of errors that can occur in software. You get syntax errors. That's, of course, where you're missing a semicolon. That's where you're missing a parenthesis. There's rules of the language and you're not following the rules of the language. Therefore, your code doesn't run properly. There's runtime errors, which is, as an example, one example of a runtime error. And there are many ways that you could go, but obviously these are while it's actually running. Oftentimes syntax errors, if you have a syntax error, it won't even get to the point where it runs. Especially in compiled languages, your program will not run at all if you have a syntax error. Runtime errors, though, the program is running and it encounters a problem. One example could be, you know, you go to write some information to a hard drive, but the hard drive is full. Well, that's a problem, and how your program handles that problem, you know, will vary, but that's a runtime error. You know, normally the hard drive's not full, but in this case, the hard drive's full. You know, I remember in the early days of Windows, you didn't have a lot of RAM, and so if you would open 2 or 3 or even 4 applications at once, you would get a runtime error saying that your memory was full and you could not run any more applications. Right? That's a runtime error. Hard drive is full. Your RAM is full. Another example is you try and make a connection to a website that is down. You know, we all use Content Delivery Network's CDN to load JavaScript files from across the internet. But what if that URL is down? What if that website is down? Right? That's a runtime error. You go to run the website, and one of the resources that website uses is down. That's a runtime error, right? The website's running, but a part of it doesn't function right. So syntax errors are when developers don't follow the syntax rules of a language. Runtime error is program is actively running, but a part of it isn't working properly. Full hard drive, full RAM, network connection isn't made. Credentials for database are incorrect. You know, all these kinds of things that can happen. Normally they work, but in this case they don't work. Right? So 9 times out of 10 you don't have these problems, but occasionally they can creep up. Logic errors are mistakes that the developer makes. in solving a problem. So like, yeah.
So in the game Aliens Colonial Marines, so there was like a spelling error which screwed up like the enemy AI.
Okay.
Someone went through, corrected it, and the alien behavior changed. It's still a bad game, but
okay.
But it's corrected a problem that a lot of people were having with the game.
Yeah. So a spelling error is probably a logic error, right? Where your variable is supposed to be named, monster, but you named it monster, something, so a spelling error could be an example of a logic error, right? That's a problem with the programmer's logic. They spelled it wrong, or the case sensitivity was in wrong, right? So that's a great example. Spelling errors. Mathematical, right? A simple example of a logic error is like, to solve a problem, miles per gallon, you take the total gallons divided by the total miles divided by the total gallons. Miles divided by gallons is miles per gallon. Well, you're supposed to divide. But what if the developer thought you had to multiply, right? You're not solving, that logic is incorrect, right? That math doesn't work correctly, right? That's a logic error. So math errors, spelling errors, the rules of the language. So spelling errors are interesting because, you could also interpret a spelling error as a syntax error, right? So the object document is supposed to be lowercase, right? And there's a difference between document and document, capital D, right? So you could, I think a spelling error could be whether that's a syntax error. Yeah, I'm going to stick with logic error because even then, that's incorrect logic. It's lowercase d on the developer. Okay, those are the three kinds of errors that are common regardless of whether you're coding in JavaScript or C#, C++, Python, Ruby, whatever. So you got this, a logic error in this example where clearly the inputs do not match the output. Right? That's bad math. The result of bad math. Or even, maybe they got some concatenation going on there when they should have been adding, right? They're concatenating. That's still a logic error because you need to parse those things into a number to do the addition. So I guess when you're talking about misspelling keywords, there we go. Misspelling keywords is a syntax error because it does have to be case sensitive. So query selector, here's a typo, select ER, right, versus select OR, right? So you're misspelling a keyword. That method is spelled OR, not ER. Leaving off parentheses, leaving off quotes, leaving off braces. You open with a single quote, you close with a double quote. That's a syntax error. Leaving off a semicolon. Again, JavaScript, semicolons are recommended. In a lot of cases, it will work without the semicolons. So that could cause a problem, but it could also not. Again, misspelling an identifier like sales tax versus sales tax. So all considered logic errors. How many people have seen this before? You have an ID of sales tax in the HTML, and then you target it incorrectly in the JavaScript with sales_tax. I mean, you've all seen it. If you've watched me code, I've done this 100 times. Right?
I've done it.
Yeah. You've all, if you've been participating in this class, you've more than likely done that. Okay? Again, this chapter, to be quite honest, is almost like bringing some things into light that you might not have known. Oh, that was a syntax error. Now I understand that's a syntax error, you know. But you've probably seen a lot of this stuff before, so this is not one of the harder chapters. But there are some very useful tools at the end that you should all learn and get comfortable with that'll help you become better developers. Let's see. Okay, problem with data and comparisons. Problems with data and comparisons. So let's talk about data and comparisons. Not making sure that a user entry is the right data type before processing it. You go to do a toFixed on a string instead of on a number, right? toFixed belongs to a number, not doing it on a string. Kind of the same thing here. Using one equal sign instead of two when testing for equality. In an if statement, you say if x double equals 10. If x double equals 10. Double equals is a test. A single equals is an assignment. Very common mistake inside of your if statement, you say if x equals 10 instead of if x double equals 10. Okay, so if you do that, if you do this mistake, if x equals 10, this will always be true because you'll just assign x to 10 and then therefore that's true. So that's not, again, if x double equals 10 is how you should do it. You've probably seen this where you've got the math that your computer that the JavaScript returns is, I'll just call it wonky. Like that should be 7.50, but when you run the math in the browser, you're going to get this output of 74950000001. And so the problem is right here. Sometimes when you do math, the results are imprecise, meaning they're not exact. There is a technical, detailed definition as to why that is, if you want to get into the weeds. But I don't think we need to get into the weeds. All you need to know is that there can be a problem sometimes when you do some arithmetic and they can give you these wonky results, and then you just need to solve it by doing toFixed. And then if you need that result as a number, you could parse float. So this takes the number, or the string, I should say, and makes it 2 decimal places, and then this turns it into a number. Let's take a look at this. This kind of talks about the use strict keyword. Slide 10, problems with undeclared variables that are treated as global. You see the two variables that are highlighted there? Sales tax with a capital T versus the typo that they made with the lowercase t. The problem, as you can see, is the case sensitivity, right? So the T should be capital. What actually happens here is you wind up with two variables. So we learned to declare a variable, you have to use the keyword let, which is not correct 100% of the time. You can declare a new variable without the keyword let if you're not using strict. So what is use strict? Use strict just enforces good coding practices. Like, for example, if you're going to declare a variable, you need to use letter const. That's a good coding practice. turns out if you don't use strict, you can actually declare a variable without the keyword let. That's what's actually going on here. There's now two variables. One variable with the capital letter T that's equal to that math. There's another variable that's equal to that. So this actually creates two variables. This variable, because it's used the keyword let, it has local scope, meaning it's accessible inside of this function. This variable that was created unintentionally has global scope because it wasn't created with the keyword let. What's the solution? The solution is use strict, and then you'll get a nasty error message when you go to run this program. It'll be a syntax error, and it'll say you got a problem. It'll say sales tax is an unrecognized variable. And you'll go, oh, wait a minute, I didn't capitalize the T, problem solved. Right? So the solution to this problem is to always use strict. And just as a reminder, what does that look like? Single quotes or double quotes, use strict, just the words use strict at the very top of your file with a semicolon at the end. Okay. Again, what that does is enforces some good practices, like using the keyword let or const to declare all of your variables. So this slide just kind of highlights, okay, when you're testing your program, you want to test it with valid data and you want to test it with invalid data. That's how testers are going to test it, right? Because that's how end users could potentially use your program. So it says two critical testing phases. Test the applications with valid and test the valid with invalid or unexpected user actions. Try to think of everything you can to make the application fail. Some applications are way more critical than others to do testing with. You know, your video games, you know, they release them with some bugs. The people might not like it, but they might live with it, right? No one's going to die if there's a bug in your video game. Like no person presumably would die because of a video game bug. Although there are stories of people who become suicidal because of video games. That's a whole different story. However, we've talked about applications. I had the alumni that came in here, I think it was Robert. He worked at Express Scripts. Express Scripts was shipping life-critical medications to people's doorsteps. And he wrote some software that was a big part of that, shipping life supporting medications to people's doorsteps. So if you ship it to the wrong address, people could potentially die, right? So you certainly want to test certain applications and need to test certain applications more than others, right? So there's literally life and death scenarios. Other applications cost a lot of money, right? So you might want to, it cost a lot of money. Certain applications, if things don't go right, you're launching rockets and the rocket explodes, real world example, cost millions or billions of dollars, right? Because of a programming error, right? I've mentioned that to you guys before. We talked about that story before, yeah, right? So certainly testing is more important in some applications than others. Okay, and this talks about, okay, when you have valid entries, inputs, what are your expected outputs, and then testing to make sure that those line up. These inputs match those outputs. And then, okay, what are these invalid entries, and what should be the, these should include entries that test the limits of the allowable values. And really, same kind of thing there. What error message should the user get when you have invalid entries? A lot of times it's very important to test the edge cases. And what I mean by that is if, okay, so like the user 21. The user's age is 21. So there's really 3 edge cases. There's below 21, there's 21, then there's above 21. Right? So you always want to test those edge cases. And for those, this will help you guys in your hands-on tests moving forward. Like if you have an edge case, that's what I test against. I always test, okay, I test against those edge cases. I test above, below, and at. Right? So those are important things to test. So, and again, this does apply to you guys. What are 2 common testing problems? Not testing a wide enough range of entries. So you're ready to turn in your test, you turn it in. What do? At the first number I come in, I throw in a number, you're like, oh, I didn't test against that. I forgot to test that number. So manual testing is a laborious process. It takes time and effort to test against a wide range of entries. But if you've got the time on a test to be thorough, you should be thorough and test against as many inputs as you can. And also not knowing what the results should be. You think about our problem yesterday with our income tax. What did I do before I solved it with JavaScript? I solved it on the board. Right? So you need to know the outputs. Otherwise, how do you know if your input is correct? How do you know if your program is correct? Right? So you need to do the math and know the output to whatever input you're giving. So again, testing is trying to break it. Debugging is fixing it. A bug is a problem. Syntax error, you're not following the rules of the language. Runtime error, the thing is actually running and generates a problem. Logic error is, you're adding instead of subtracting. You're multiplying instead of dividing. When this is a term that I didn't cover. Throwing an exception versus throwing an error. These are very similar. An exception an exception is typically a problem that crashes your software. So an exception is an object. An exception is an object that is generated when a problem occurs that can crash your software. How about that one? That's a better definition. So what is an exception? Number one, an exception is an object. Just like an array. An array is an object. The document is an object. The window is an object. An exception is an object that occurs, and if you do not handle it properly, it will crash your software. Right? So that's what an exception is, and you will learn techniques to keep your software from crashing when those exceptions occur. An error is not an object, a traditional throw an error though. So throw an exception. Exception is an object that's generated when a problem. See, the keyword throw means the programmer creates an exception object. So there's a reason why we would do that. So, but the way I'm going to define these right now, an exception is an object, an error is a problem that can be fixed with if-else and loops. And so, you know, an error, you know, if a user entered a negative number, you could say while number is less than 0, you know, get prompt the user for the number again. Mark, you need to stand up and get a drink. Thank you. You awake?
Oh, yeah.
All right, hang in there. The thing I want to highlight here, because I'm spending a little bit of excess time here, an exception is an object-oriented approach to fixing bugs. And so an exception is an object that you use to fix problems with. Whereas a traditional error, you can just use things like while statements and if-else statements. So exception handling versus error handling, those are two different things. One's an object-oriented approach that uses objects. One is kind of more of a traditional method. Okay. We've been going for about 40 minutes. Let's take a quick 5-minute break. All right, so the first part of the lecture, first half, was really just the theory, and now this comes into the practice. The practice portion. All right, so step one, I'm just going to use this miles per gallon one because I just got to pick one. So I'll pick miles per gallon .html. You know, right-click and inspect brings up the developers tools. Get this extra window down here. I typically close this one. So, you know, I typically close that. And right-clicking and inspecting is the long way of going about it. F12 is the fast way of doing it. All right, so F12 on your keyboard. Now, some of you on your laptops, you have to hold down function F12. It's kind of annoying if you ask me. I just like hitting F12. But it is what it is. So you're very familiar with this because we used the developer console. So it's like automatic. Open up the browser, F12, right? The first thing you want to look at is this console window. And if you got a problem, the first place you'll see it is here, is console. Right? So F12, click on console. And I don't know, let's break something. Right, so my query selector is now saying MPG form, capital F, that should break, so right away, cannot read property of null. You're gonna see that a lot. Cannot read property of null. So that error right away, you know, that error says to me that your selector isn't selecting the HTML property properly. So the selector not selecting the HTML properly for one reason or another, typo, you know, whatever the mistake you're making. So when it says cannot read properties of null, immediately think my JavaScript is not selecting my HTML. Right? So that's the first error. And it's saying something about add event listener cannot read properties of null. Null meaning it's trying to select this thing, but that thing is empty. It doesn't exist. The other thing is it does give you a line number. It says line 13. And you can even click this link. Let me put that in screen. You can even click on this link and it will highlight. Now notice what it does. It opens up the sources. And it actually highlights the line that the error. Now notice what it says, uncaught type error. Remember we talked about exceptions being objects? That is an exception object. Type error is an exception object that's crashing your program. I just wanted to show you, it'll highlight the line so you'll know exactly where to look. Now, you know, line 13, and actually the problem was on line 12. So when I say you know exactly where to look, you know exactly where to start looking. It's around that line is how you need to think of it, right? The error is around line 13. It might not exactly be line 13. So open up the developer tools, hit the console. If the console doesn't have any problems though, and you're still having an issue, that's what it goes on to talk about. Let's see. So F12, developer tools, console versus sources. Okay, what can you do with sources? If the console is clean, you want to then go to sources. So F12, console is clean, let's go to sources. This tool called a breakpoint. I've taught coding enough. Breakpoints are the tool that people like, they have a hard time learning, but it's also one of the most useful tools to learn how to troubleshoot and fix your own problems. So if you want to fix your own problems, which you all do, you know, for testing purposes or just being good developers, the better you are at using breakpoints, the better you will be at fixing problems, right? So the first thing you have to learn is how to use the console and how to read those like error messages. But if the error messages are clean, you might have like a logic problem. And in order to understand your logic problem, your logic bug, you want to use a breakpoint. The better you are using breakpoints, the better you are going to be at troubleshooting. The better you are at troubleshooting, the better you are at JavaScript, right? So breakpoints are very important. The way breakpoints work is you see these line numbers over here? These numbers? You want to click on one of these numbers where you suspect the problem is. If you don't know where the problem is, just click where you know the executing starts. Like I know line 14, that's basically where the start line is. When I click the button, line 14 should run. What it's going to do is it's going to stop the JavaScript at that line so that you can execute your JavaScript line by line and observe how it's working. You can observe the flow. You can observe if it's looping. You can watch that loop execute. One function calling another function. You could just watch it execute. And while you're watching it, you can observe the variables. The variables all have values and they're changing. They're going higher, they're going lower, they're getting strings, they're numbers, they're just changing all the time. So let's throw this in as an example. Yep.
So is this, I guess, more efficient than using the console log command?
You can use them both together. You can use them both together. You can use console.log. And so I don't know about more efficient. I'll give an example. If you've got a loop that's looping 1,000 times, a console.log is a great tool because you don't want to step through that loop for 1,000. You don't want to necessarily use this tool for a loop that's iterating 1,000 times. But if you just want to kind of slowly step through a couple lines of code, you could use a breakpoint. So the short answer is you can use them both. So I'm going to say you drove 100 miles and you used 2 gallons of gas. I'm going to click calculate. Now notice it says paused in debugger. And this kind of highlights this line. Now this window over here, where my mouse is, these are where our variables are. These are also our controls right here. These are our controls. We're only going to focus on 2 controls. Right? This control in blue, that just gets you out of the breakpoint. Notice if I click on that, I'm done with the breakpoint, and the rest of the JavaScript runs. Okay, so now it went out of break mode, and it's not broken right now, so it gave me the right output. Okay, so if I ever want to get out of break mode, I hit that little blue continue button, resume, I think it is. Okay, but let's change this up. We say 100 miles and we say 3 gallons used. Now let's hit calculate. Okay, so the first one is just resume, and again that gets us out of the breakpoint mode. We're in breakpoint mode right now. This part of the screen is gray. This line is highlighted blue, and you can look at your variables over here. The next control that's interesting is the step into. These are the 2 controls that you can really use right now. This little down arrow. Watch what happens. I click the down arrow. You see the highlighted line goes to the next line? Now line 16 has not executed yet. Line 14 executed, but 16 has not executed yet. Notice in our variables, it says gallons is undefined and miles is undefined. But once I execute line 16, I'm gonna hit the down arrow. This will execute line 16. So now I see miles has the number 100. It's the number 100 because it's not in quotes. If it was in quotes, I would know it's a string. It's not a string, it's a number. All right, so you could tell its data type by looking at miles:100 right here. That would be what I would expect. You can even hover miles and it'll tell you miles is now 100. Gallons is currently undefined. Why? Because line 17 has not executed. How do I get it to execute? I step into. Right now my console is, that was from the last time I ran it. Because now this is 103, right? So that was the console log from the last time. If I execute line 19, now I can go to my console and see that console log wrote to the console. This is an amazing tool, right? You're just stepping through your code line by line. Like naturally when something doesn't work, you go into here and you look at it and you go, okay, what's going on, right? But that's what you've been doing up until this point. You're now adding new tools in your tool belt to fix your own code, right? Because there's a problem that we have as human beings. When we write code, we tend to think that our code is not the problem, right? We tend to think that something else is the problem, right? But using this breakpoint, really what this is doing is this is getting us to critically look at our own code. Line by line, critically look at every step along the way and how it's working. We then have an if statement. That if statement must have been true. How do I know that? It went in the if statement. We're now on line 22. Line 22 calls a function miles per gallon. Notice where it goes? It went up to line 3. What is line 3? Line 3 is our anonymous function that's stored in a constant called miles per gallon. It takes 2 inputs. Those inputs, if you hover, 103. It returns 100 divided by 3. Let's step into it now. Where does it go? Now miles per gallon holds the result of that math. 33.3 repeating. We then output 33.3 repeating, 2 fixed with no decimal place. Miles per gallon. We chop off with 2 fixed 0. And then we focus the miles. And it's done executing. So again, the two important things. Now, here's another thing. I'll say 100, 104. 104, again, I'm just going to show this. If I'm like stepping through this, I'm like, okay, I'm done. Let's just hit continue and it'll run. Those, I mean, what are those? You got to click the right tab. You got to click on a line number to insert the breakpoint. You click on the line number. If you don't know where to insert it, if you don't know where to put a breakpoint, just put it on line number 1. Put it at the start line and just start from the beginning. They're not that big yet. Our scripts are not thousands of lines of code.
So
Yep.
we actually had one yesterday when we were working on this sales tax calculator.
Yep.
So there was like a point where it was dividing by 100 the tax rate.
Yep.
And it's supposed to be like the tax rate was like 12. It couldn't go over 12, but we were adding like 25 and it was letting us do it. And so we used that, you know, this, what do you call this again?
It's just a breakpoint.
So we used the breakpoint to go through, and then we saw it was dividing by 100 at the wrong place, and it
Perfect.
wasn't validating, so it was pretty cool to use it.
Yeah. So you used it and it helped you solve the problem. And so you can kind of see how using this tool helped you write the code correctly. Yeah. So how to set or remove a breakpoint, I guess I didn't talk about how to remove it. How to remove it, click it again. It goes away. So add a breakpoint, click on the line number, remove it. Now you could, look at this, you could do this, and people do this. Every executable line of code, you could put a breakpoint. At this point, not necessary to do that. Put in one breakpoint, put it at the beginning, and just step through every line. Okay? If you've got a large script with thousands of lines of code, the way this works is you could step into, and then when you hit resume, it just jumps to the next breakpoint. Notice it went to 17, now it'll jump to 19, now it'll jump to, I don't know, 31. I don't know why it skipped 23, but whatever. Oh, it's because it was empty. All right, so that's how that's kind of useful, but at this stage, you don't need it. You don't need multiple breakpoints at this stage. At this stage, you just need to get comfortable with one breakpoint. You need to know the step into, you need to know the resume. There are other controls here, and we could break that down, you know, step over and step out, but, you know, again, kind of not even needed. And they talk into, step into, okay. Step into goes into the method call. So if you've got a method, it'll step into the method. Step over would skip over the method call. So if you've got a function that you know is working and you don't need to debug it, you can step over that call, right? Step out is if you go into a function call and you're troubleshooting it and you're like, oh, it's not the problem, you could step out of it. So it's like going in and then going back out. That's all it is. And then we already demonstrated resume and how that works. All right, I showed you how to look at the variables, right? Stepping through code. Now, then the question becomes, when do I want to use a log versus the step-in tool? And stepping in is awesome until you can hit like a loop. And this is the best example I can think of is, you know, if you've got this for loop that is just this very long for loop. This loop is iterating 1,000 times. And then you've got some math that is outputting a bad value. Well, instead of stepping through this loop and watching it execute 1,000 times, you could just do a console.log I. Right? And so what that does is it just puts the output of I to the console. And this is called tracing. Tracing is this idea of tracing the value of a variable throughout the execution of a program. So you can see that this variable is going up by 1 from 1 to 999. Right? You can trace that in a console.log. That's what a trace is. A trace is following the trail of a variable throughout the execution of a program. Now in this case, we're tracing the value of I throughout a loop. But sometimes your variable, your data can go from method A to method B, from method B to method C, from method C to method D. Right? So you might need to trace the value of a variable throughout multiple method calls. Now that is called tracing a variable through the call stack. The call stack is the list of methods that have been called to get you to where the program is executing. Again, I just like saying A calls B, B calls C, C calls D. That's your call stack. That's the order, or those are the methods that are running in order to get you to that point of execution in the program. So those are two concepts. What is tracing and what is a call stack? And those are both, kind of terms in this chapter. So when you're doing a console.log, that's a trace.
Can you explain call stack again?
Yeah, call stack is this idea of, okay, so let's just say A calls B, B calls C, so okay, whenever the window loads, we call A. When A loads, it calls, A could do something, call B. B could do something else, call C, and C has an alert that says, "Hi, Mom." So call stack is just what methods have been called in order to be executing line 25 in the program. So the call stack in this case would be, well, C was called inside of B, B was called inside of A, and A was called when the page loaded. So think of it as the breadcrumbs. The call stack is the breadcrumbs.
So is the call stack only there after A runs, it gets it?
Yeah, the call stack is if I inspect this, let me see if I can do this. Inspect let me see if I could put a breakpoint right here. Okay, I'm gonna put a breakpoint right there. I'm gonna hit refresh. So line 25 has not executed yet. This is perfect. See the call stack right here? CBA. Can you see that? Right here where my mouse is?
Oh, yeah.
C is currently executing. C was called from B at line 21. B was called from A at 15.
So it's literally just like part of the browser that can see call stack?
Yeah.
Okay.
Yeah. It's built into the troubleshooting window. So, in other words, we're executing line 25, but how did we get to that point? Understanding where everything was called.
Thank you.
Yeah. I'm glad you slowed me down there, because that's very useful, this call stack. Because what if you've got a program with 100,000 lines of code? How do we even get to the point that we're executing line 300,000, 30,000 or whatever? How do we even get to that point? Oh, well, that was called here and that was called there.
So you can use it to like trace it backwards.
You use it to trace it backwards.
It's like,
Yeah.
what is it, Little Red Riding Hood?
Yeah, it's the breadcrumbs, right? Is that the story of Little Red Riding Hood? Yeah, leaving the breadcrumbs through the trail.
No, that's Hansel. Yeah.
That's Hansel and Gretel.
Never mind.
I'm a dad now. I should know this. So there's a little screenshot of tracing the value of a variable throughout a loop. Three more methods of the console property, right? So we've used console.log. There's also console.error. Let's just see what console.error looks like. Right? That just gets you a nice little red error message. So instead of being in black, it's in red. Big whoop. Console.warn.
I bet it's yellow.
Yellow. Yep. Okay. No big deal there. If you wanna give error messages in red, you can mark it in red in the console. That just helps you, right? A red message would be more of a problem than a black message. That's just a developer tool to help developers. There you go. Now, let's do a console.trace. You could probably guess what console.trace is going to do here. It's actually not even as useful, because it says C is called at line 25. That's okay. Come on, what am I missing here? It's more useful to go under sources and see the call stack. I expected that to be the call stack, the trace. How the stack trace looks, it's kind of what I expected to see. It's kind of like just basically seeing the call stack inside of this trace. Let's see, what am I doing wrong?
Did you create a loop? Isn't that what it's looking for?
well, it's the call stack. They call it the stack trace. It's the call stack. What they're showing here is that, hey, calculate FV was called on line 9. Let me look one more time. Let's see what I got here. We already know how to look at the call stack. Refresh. Console.trace. Resume. Take that breakpoint out. Not really necessary. Oh, there it is. I just had to refresh. So what are we looking at here? We're looking at the call stack. But we're looking at the call stack in the console. That's what I expected. So this says line 25, B calls C at line 21, right here. A calls B at line 15. So that's all that is. Call stack and stack trace, terms used interchangeably. Trace execution is just following the call stack, going through it. And then lines 30, 31, and 32, this is what we spent the first 30 days of class doing, looking at the HTML, using the developer tools, and looking at the CSS using the developer tools. So you guys know how to do that. That's not new at all. All right. Troubleshooting is done. Class is done.